All right, boys, so now we start our lesson on levers. In this lesson, I would like you to be able to describe the three types of levers and identify the input force, load force, and fulcrum on a lever. This is what your notes are going to look like. What I'd like you guys to do is describe class 1 levers, class 2 levers, class 3 levers all over here. I'd like you to be able to draw a picture of these different levers and what they look like, please. So that is what I'd like you to do here. There is a backside to this page where you can draw one sort of summary of what a lever is, because I haven't provided space for that. And it is a pretty simple definition. It shouldn't take up much space, but here we go. This is a definition of a lever. A lever is a rigid bar that pivots on a point called the fulcrum, sorry. So let me break that down for you. Rigid bar, it should be highlighted tool. Rigid bar means that it is straight and it's firm like a plank. If something isn't rigid, it's like wet spaghetti. It's just going to bend, or it's like a ruler that bends. Okay, those flexi rulers, they're not rigid. A rigid arm is firm, it's hard, and it's straight. Okay, or it doesn't actually have to be straight. Just needs to be firm. So that's what rigid means. So if you take a look here at this picture, this is the rigid arm. It's this part over here. It's a flat, straight piece, and then what it needs to do is it needs to do this. It needs to pivot at a point. So pivot basically means it needs to turn. So if you look here, this is where it's going to pivot. When he jumps on it, it's going to go down, this side's going to go up, and this side is this point over here is going to twist, also known as pivot. A pivot is another word, pivoting is another word for twisting, okay? All right, and the rigid arm is going to pivot at a fulcrum. And a fulcrum is the name for the point at which it pivots. Okay, that's its special name there. That's what the point that pivots is called the fulcrum. All right, so that's what a lever is. Take time, write some notes on the back page, highlight what you need to, draw a picture if it helps. Okay, describing rigid bar, pivot, fulcrum. Those are 3 words you're going to need to be able to describe if you are to understand this objective. All right, cool. So, levers. Let's go. Come on. There we go. A lever is made up of a load force, and the load force is a force on the lever being applied by the object you want to move. Input force, the input force is the force applied to the lever to move the load, and the fulcrum is the point at which the lever tilts or turns. So I know I'm rushing through this. You guys can pause the video to take notes, but let me explain it first, and then I'll tell you when to pause, okay? So there's 3 parts to a lever. So first off, we said a lever is a rigid arm that pivots around a point called a fulcrum. That was your definition. A lever is made up of 3 parts, though. For a lever to work, you need a load force, you need an input force, and you need a fulcrum. Let's start with the fulcrum first, because we've actually covered it. It's the point at which the lever tilts. So it's the point at which the lever twists. This is a good symbol to help you remember what a fulcrum is. A triangle with 2 arrows twisting round it. Okay, to let you know, it's a point. It's right at the top of that triangle where the lever is going to twist. Okay, and that's what those arrows represent. So then the input force. The input force is the force applied to the lever to move the load. So a lever, what it's supposed to do is you're supposed to apply force to it to move something else. Input force is the force you have to apply to it. It's you pushing, or the heavy weight you put on it to make something else move. That's what the input force is. It's what you are putting in. So that's the input force. And then the load force, also known as the output force, is the load force is the, sorry, I thought I had the highlighter selected again. The load force is the force on the lever being applied by the object you want to move. Now that sounds a bit confusing, but it's basically load force is the object you want to move. That's a simple way to put it. So input force is you putting a force in to move an object. Load force is the object you want to move, and fulcrum is the point at which it pivots. I would pause now and take your notes. Cool, moving on. So there are 3 types of levers. Class 1 is where the fulcrum is between the load force and the input force. We are going to go over this in our next video. Lever 2 is the load force is between the fulcrum and the input force. And class 3, the input force is between the fulcrum and the load force. Okay, sorry, I skipped ahead there. So those are your 3 classes. It basically has to do with what order everything happens in. So the load force would be 1 first, then the fulcrum 2, then the input force would be 3. Okay, that's for class 1. For class 2, the load force would be 2, and for class 3, the load force would be 2, and then we can just do 1, 3. So the same, looks like the same order, we just switch the words around. But what this means is, so for 1, the fulcrum's in the middle, okay, and then we put our load on one side, and we put our input on the other side, and you do an I over there. So if we do this as 1, 2, 3, that's what that's going to look like, whereas the other example, number 2, in the middle you're going to have your load, then that's your rigid arm. Then first thing you're going to have your fulcrum over here, and that's going to be your input force over there. So you see how it looks a bit different to the first lever we did? And then the third lever, here's your lever, that's the rigid arm. You're going to have the input force in the middle. You're going to have the fulcrum on one side, and you're going to have the load on the other side. All right. So don't worry, we'll go into each one of these and the benefits of them. But those are the 3 classes. You can write that down in your notes where they go. And that's it for this video. Well done, boys. See you in the next one. Cheers.